My name's Alex Kroll,
My name is Zach Harrington.
and this is our senior project, which is fuel injection conversion.
Our objective today is background, what's available, why, port fuel injected, deliverables, design, and calculations.
Background. My truck is a 1959 Ford F100 with a 292 Y block. The Y block had a lifespan from 1954 to 1962, and due to the short lifespan of these engines, there is not a big aftermarket following and not a lot of systems for fuel delivery out there. So this is the port. Background, these are stacked ports. They're very unique to this engine, and due to that, there isn't a lot of systems out on the current marketplace.
Because it's hard to get the fuel injectors into those ports.
So what's available on the market? There is throttle body fuel injection kits, which is essentially a carburetor, but it has injectors instead of a controlled leak. And in terms of fuel injection, that's the only option as of right now. Wide port fuel injection. Improved fuel economy, improved drivability, improved reliability of the engine with starting and just constant power. I can do cylinder to cylinder control, whereas throttle body is strictly at the beginning of the intake. So one cylinder could be running rich and one could be running lean. And just improved fuel delivery, and that's again cylinder control. It's injecting at the port instead of at the very beginning of the intake manifold.
Our deliverables, what we want to do is we want to improve fuel economy to 18 miles per gallon. Right now we're estimating that the truck's getting about 10. We should have no problem reaching that. And right now we want to improve the horsepower to 250. I believe stock is
178.
178. We hope to have the truck ready and completely back together, ready to go April 15th of 2017. And the way we're going to meet these deliverables is we're going to set up a test where Alex and I both run at a constant driving speed around town here with 1 gallon of gas in the truck or 2 gallons and see how far we can go with it. And then obviously Motorsport has a dyno, and we're going to put the truck up on a dyno set to check the horsepower out. Right here is a design that I've done so far, just a rough draft of the intake manifold. You have, right here is a water or coolant crossover with a thermostat that has to go in here to keep the motor, to let the motor heat up, and then a valve will open to let the fluid go back into the radiator. You have your runners right here going up to your plenum, and then right here is right where your throttle body will go. Right now, the problem is, just like what we said before, it is a stacked port, and it's not just like you can do with side-by-side ports where you can just put the injectors right here. We actually have to put the injectors over here, so we're looking at running 8 injectors. That's our first design that we want to get to. With this design I've done up, we're able to get 8 injectors in there. The other problem too is we are looking at casting it, 3D printing it, and also bending the pipe and welding it all together. Problem with welding it is not all the welds are going to be the same. There's a lot of man labor in welding it, so we're actually going down the route of 3D printing it.
So other systems that need to be designed and updated to accept fuel injection is the fuel system. Right now it's a mechanical fuel pump. It needs to be updated to 2 electric fuel pumps, a low pressure fuel pump to go into a buffer, and then a high pressure fuel pump to send to the fuel rails. It also needs a return line ran on it and different fuel filters to accommodate higher flow. The fuel tank is currently in the cab of the truck. Right now, plans are to keep the fuel tank in the cab of the truck and redesign the pickup or the fuel plate on the tank to accept a return line. The other design that needs to happen with the systems is ignition distribution. Right now, it's a mechanical breaker point distributor in it. we need to convert that to a electronic distributor with a Hall effect sensor to trigger the injectors. So the injectors are going off at the right times when the ports are open and every time it sparks. So we get enough fuel and the fuel in the right place at the right time. Calculations. We need to size the throttle body according to how much displacement the engine is. So right now we're looking at doing 650 CFM through the throttle body with a 4.8 liter engine. That's how much displacement my engine currently has. That is about right. And then later on down the road, if forced induction or anything else, we can up that. But for naturally aspirated, probably 650 CFM is going to be where I'm at, but there's going to be more calculations on that. I need to size the fuel pumps. They need to supply enough fuel at wide open throttle so the injectors don't run out and the rails do not drain themselves. So that's going to be calculations to make sure that the fuel pumps can supply enough fuel to the rails to accomplish that.
Another one, if we go down the route of welding it and manufacturing it that way, we need to do some weld calculations. Then also there's going to be some motors, so there's a lot of vibrations and moving the motor and the motor actually moving down the road. So we need to do bolt clamping loads under bolting too, and also we need to use SolidWorks and use flow simulation to see the flow patterns as it goes through the intake manifold, to make sure that all the ports have the same flow. We don't want to have 4 of the cylinders getting a higher flow than the other 4 of the cylinders due to the different length of the runners. So we need to play with the diameters and also the lengths of them to get the same flow through all the ports.